Hey everybody, this presentation is going to tell you a little bit about air masses, what they are, how they form, and why it's worth knowing about them for weather. So, first question, well, what is an air mass? And so, I want you to know that it's a large body of air that stays over a uniform surface for a few days. By being over something that is a uniform surface, it begins to take on the characteristics of whatever is below it. So we know that we're talking about temperature and humidity. And when you think about temperature and humidity for a big patch of air that's spanning hundreds of square miles, if it's over the ocean, it's going to take on whatever temperature, and we obviously know that that's going to be a high humidity environment because of all the water around. If it's over the land, we would expect that it's going to be much drier. So if we consider like how these things affect our weather, um, if you're watching the weather forecast and you look at this little insert of a weather forecast, they say Saturday, 52 degrees, and then Sunday, the high temperature is 34. Well, how does that happen? Usually, that's a shifting air mass. If air masses move, they're going to make some significant shifts in your weather. So the movement of air masses can get you some really big changes from one day to the next. So if we consider, well, like, what about an air mass that's forming over Mexico and it's going to then travel to the United States? What is it going to be like? Well, we know that coming from a place that's further to the south, it's getting more direct sunlight, we would expect we're going to have warmer temperatures, and the fact that it's over land means we don't have a lot of H2O to evaporate into the air, so we're going to expect lower humidity levels, lower dew points, and so that's what we'd expect, warm and dry air coming from an air mass that forms over Mexico. So when we consider that example, we can then figure out how all air masses are going to work, and then we look at the naming process. How do we name an air mass? So there are rules, and this is worth getting to know. So first, the first word that you're going to use to name your air mass will tell, did the air mass form over land or did it form over water? If it's forming over land, we call it a continental air mass. If it's forming over water, we call it a maritime air mass. The second word is going to tell us, did it form in a warm environment? We would call that tropical, or if it forms in a cool environment, we refer to that as polar. The third word, and the third word only applies if it forms over a body of water, you might name the air mass or the body of water where the air mass actually formed. There is no third word if it's from over land because we only got two options here in the United States. It's coming from Canada if it's a polar air mass. It's coming from Mexico if it's a tropical air mass. So summarizing, these are the air masses that affect us, and you note the abbreviations. So MP standing for maritime polar. And so if we look over in this region up by Alaska, maritime polar air mass is forming here, traveling into the United States, influencing weather. Maritime tropical air masses down here. These would be maritime tropical Pacific air masses and maritime polar Pacific when we're talking about up here. We notice continental tropical, reserved for anywhere over the southwest and then down into Mexico, is considered a continental tropical. Maritime tropical, you note that they have these two different maritime tropicals, and one is over the Gulf of Mexico, one is over the Atlantic Ocean. And that's where having the name can be helpful because the Gulf of Mexico, being a smaller body of water, is going to tend to have slightly different characteristics than what we would expect for the Atlantic Ocean. And then, we have continental polar over Canada and maritime polar. Now, you did notice this CA standing for continental Arctic, and so this particular would be air mass would be even colder than the type of air mass that we associate with continental polar. These don't always reach down into the United States. However, there are some circumstances where you can get those Arctic air masses making their way all the way down, usually in the winter, and that's when we would get those really cold periods. All right, so suppose we're looking at a station model weather map, and we are looking at a zoomed in section of Kansas right now. And so we're looking at Kansas on March 26th. And so we have to think, okay, so March 26th, it's noon. What would we expect? Well, in terms of a temperature, this 28 is kind of on the cold side for noon on March 26th. When you look at the dew point, it's 14. That's pretty far away relatively from where the air temperature is. You'd have to cool this down significantly in order to saturate the air. So what we're seeing is that we would have a cold and dry air mass. So what's the name? This would be a continental polar air mass. And so this is how we can use data in order to figure out the name of an air mass. So the final thing to think about as we're kind of saying, okay, we understand how air masses form, we understand how they can influence our weather, we know how to name them. Well, what would happen if we get two different air masses and they move into each other? They're colliding. What we are going to see is they don't mix very well. Air masses tend to stay separate. And here's a little visual for you to think about. So the beaker on the left is one that resembles what we might get when you have two different air masses that are colliding. They tend to not mix. When we think about, well, why would that be? Consider one is a very cold air mass, one is a very warm air mass. The key to why don't they mix well is density. And so what we're going to explore in future classes will be, well, what happens exactly when you get two different air masses hitting into each other and they don't mix?